Yes, guys, good evening. So, today we are going to discuss first Hinsberg's reagent test. Now, this Hinsberg test, it is a very useful test for the distinction of primary, secondary, and tertiary amines. Okay, so it is a test to distinguish between primary, secondary, and tertiary amines. Okay, so in this case, what we do, amine, primary, secondary, or tertiary, it is shaken with Hinsberg's reagent. Now, what is this Hinsberg's reagent? It is benzene sulfonyl chloride. Okay, so with this reagent, this is called Hinsberg's reagent. Okay, so in with this reagent, amine is shaken in the presence of aqueous KOH solution. Okay, excess of KOH we have to add. Okay, so reaction taking place, they are different in case of different amines. So with primary amines, what happened with primary amines? See, primary amine react with benzene sulfonyl chloride. See, this is benzene sulfonyl chloride, Hinsberg reagent. Okay, now this Hinsberg reagent react with primary amine. Okay, this HCl is removed and we get sulfonamide. Okay, this sulfonamide is formed, that is called N-alkyl benzene sulfonamide. N-alkyl benzene sulfonamide. Okay, so this N-alkyl benzene sulfonamide formed. Now, once it is formed, sulfonamide, yes, it is visible, right? Okay, what it means, beta? Bengali language, it's okay, but what it means? So now we add aqueous KOH, excess of aqueous KOH. So when this excess of KOH is added, because of the presence of this H, it behaves as an acid. Okay, and because of this acidic nature, it can react with aqueous KOH and we get, because acid base reaction takes place, so there is a formation of salt. Beta ji, names are also important. R, this negative, okay, and K positive. So obviously this potassium salt is formed, which is soluble in water, soluble in aqueous KOH. Okay, and this soluble KOH, when we acidify it, we get back the same N-alkyl benzene sulfonamide, okay, which is insoluble. So in aqueous KOH, the compound is soluble, and on acidification, it becomes insoluble. So we get soluble sulfonamide in aqueous KOH and insoluble sulfonamide when it is acidified. So this is about primary amine. Okay. Okay, Harshil, good evening. Charitra, good evening. Got it? So primary amine, it forms an alkyl benzene sulfonamide. Okay. First of all, which dissolves in aqueous KOH, and upon acidification with excess of HCl, what happened? We get insoluble sulfonamide. हर्षिल डोंट वरी, मैं तुझे कॉल करता हूं, है ना. वी विल डिस्कस इट. नाउ सेकेंडरी अमीन. सेकेंड इज secondary amine. So in secondary amine, you know, secondary amine is like, okay, first hinsberg reagent. This is the hinsberg reagent. Now in secondary amine there is only one H. Okay, this is secondary amine. So again, removal of HCl, and we get this product. Okay, so we get NN dialkyl benzene sulfonamide. Okay, so when this NN dialkyl benzene sulfonamide is formed, okay, this is, you know, this has no H, so it is insoluble in aqueous KOH. It is insoluble in aqueous KOH, and even on acidification it remains insoluble. Even on acidification it remains insoluble. Okay, insoluble in KOH, even on acidification it remains as such. Even on acidification with dilute HCl, that makes no difference actually. Okay, so first of all, with primary amine, the sulfonamide formed is soluble in aqueous KOH. With secondary amine, sulfonamide formed is insoluble in KOH. Now third, tertiary amine. In tertiary amine, yes, tell me, this is sulfonamide and this is tertiary amine. Yes, is there any reaction? Okay, Praharsh, good evening. Yes, tell me, is there any reaction between hinsberg reagent, that is benzene sulfonyl chloride, and tertiary amine? Okay, Varun, very good. Good evening. Where is Yash? So there is no action at all because there is no NH. Say in primary amine there are two NH. Okay. In secondary amine there is one NH. And tertiary amine there is no NH. Therefore, there is no action and it is insoluble in KOH. Okay. But on acidification, what happened? You know, when you acidify it with dilute HCl, obviously tertiary amine will react with HCl and we get the salt. That is, clear solution is formed. Okay. See, this is obviously soluble because salt is formed. So this is trialkyl ammonium chloride. Right? Very good. So say in primary amine, sulfonamide is formed. Sulfonamide formed is soluble in aqueous KOH, and on acidification it forms insoluble sulfonamide. In secondary amine, again sulfonamide is formed, okay, but that sulfonamide formed is insoluble in aqueous KOH, and even on acidification it remains insoluble, okay. But in tertiary amine there is no reaction with benzene sulfonamide, okay, and it is insoluble in aqueous KOH, but on acidification it becomes soluble, right? Clear solution is formed, I can say. So by the same test we can separate them. We can separation of primary, secondary and amine, tertiary amine can takes place with the same test. What we do? With Hinsberg's method, we can separate them. How do we separate? Can you tell me? So keep in mind, this is an excellent method for the separation of amines. What we do, we have a mixture of primary, secondary, tertiary amine. Let us say we have mixture of primary, secondary and tertiary amines. So we treat the mixture with Hinsberg's reagent. See, this is mixture of primary, secondary and tertiary amine. Okay, we treat it with, I will make a flow chart. Okay, we treat it with Hinsberg reagent. Okay, so on treatment with Hinsberg reagent followed by aqueous KOH, what would happen? You know, tertiary amine remains as such. Secondary amine forms sulfonamide, which is insoluble, and primary amine that also forms sulfonamide, which is soluble. So these are the three products formed. Okay, now on distillation, now we distill the mixture. On distillation, what happened? Tertiary amine distilled off. Tertiary amine distilled off because it is only tertiary amine. Okay, sulfonamide is not formed by tertiary amine, so tertiary amine distilled off. Okay, so tertiary amine is separated. Now we have mixture of sulfonamides of primary and secondary amine. Now you know this remaining mixture, we filter it. The remaining mixture is filtered. When we filtered this remaining mixture in the filtrate, we have soluble sulfonamide, that is sulfonamide of primary amine, and in the residue we have sulfonamide of secondary amine, because you know sulfonamide of primary amine is soluble in aqueous KOH and it is insoluble in KOH, right? So in this way we separate the sulfonamides. Now these we have three parts now. See, tertiary amine is distilled off, that is separated. Now we have sulfonamide of primary amine, which is like this, and alkyl sulfonamide, benzene sulfonamide, and NN dialkyl sulfonamide, means sulfonamide of primary amine, sulfonamide of secondary amine. Okay, and these sulfonamides now they are hydrolyzed with the dilute HCl, with dilute HCl to regenerate primary and secondary amine. So in this way, we get the desired products. So we get primary amine, and secondary amine. So in this way, we can separate them, and along with benzene, sulfonic acid. Right? So we can separate them. Okay. So Hinsberg reagent test is used to distinguish and separate primary, secondary, and tertiary amines. Right? So this is all about amines. Now next part is diazonium salts. So diazonium salt in for this year, this part is not in the syllabus. Okay, but only for the board exam. But in competitive exams, there may be the questions of diazonium salt. Okay, so we will do it. So diazonium salt, what is diazonium salt? Diazonium salt, it is, this is most reactive derivative of benzene. Okay, aromatic primary amines can be utilized to prepare it. This is benzene diazonium chloride, or we can write it as simply N2 positive Cl negative. So these are the benzene diazonium chloride, or even we have benzene diazonium hydrogen sulfate like this. Benzene diazonium hydrogen sulfate. Okay. So structure of diazonium salt, it is like C6H5N triple bond N Cl negative, and this N get positive charge. Why? Because here see nitrogen form 4 bonds. Okay, so that's why nitrogen get positive charge, and that's why it is highly reactive derivative, because N2 gas is more stable, so that can be easily removed. And to prepare diazonium salt, we carry out diazotization reaction that we have done earlier. Diazotization. So in diazotization reaction, what we do? We first take into account solution of primary amine. Now this primary amine, first of all, it is treated with HCl in ice cold solution. Okay, ice cold means 0 to 5 degrees Celsius. Okay, 273 to 278 Kelvin. So first of all, we get anilinium chloride, anilinium chloride or aniline hydrochloride. Okay, after the formation of aniline hydrochloride, second part is sodium nitrite react with HCl in the same conditions, ice cold. So we get NaCl along with nitrous acid HNO2, or we can write HONO. Nitrous acid is formed. Okay, and then this aniline hydrochloride react with nitrous acid in ice cold solution, and we get the desired product, that is diazonium chloride, benzene diazonium chloride. And this is highly reactive. That's why we have to keep in mind few points. We can say them as a precautions. Okay. So diazotization is carried out under some precautions. So what are the precautions? First of all, it is carried out in ice cold solution. Why in ice cold solution? Tell me. What happened if temperature is more than 278? Yes, Sahil, Ashish, Harshil, Varun, Praharsh. Saad, Charitrya, Rishi, where is it? Rishi? Why ice cold solution? Because if temperature is greater than ice cold, means more than 278 or more than 5 degrees Celsius, then diazonium salt formed that will react with water above 5 degrees Celsius. Then phenol is formed. We have discussed it earlier. We get phenol instead of diazonium salt because it is highly unstable. Only under ice cold conditions it is preserved or it is stable. It can give phenol. Very good. Other condition, first condition, ice cold solution should be there. Second condition is HCl added must be in excess. We have to add HCl in excess. Must be added in excess. Why is it so? At least 3:1 ratio. Means HCl is to aniline ratio should be 3:1. Okay, maybe more than that, but at least it is 3:1. Why? Because first mole is required to form aniline hydrogen chloride. Second mole is required. Second mole of HCl is required to convert sodium nitrite into nitrous acid. Okay. And for what purpose third mole is required? Third mole is required for what? Yes, primary amine is only used. Okay. Secondary, tertiary amines are not used. But tell me, third mole, for what purpose we use third mole? Third mole is used to check. Otherwise, what happened to make the solution sufficiently acidic so that amine is not there, aniline is not there. Aniline is converted into aniline hydrochloride. Okay. Otherwise, diazonium salt form coupling with aniline. It form azodie that we will discuss in the next case. Okay. So third mole is required to make the solution sufficiently acidic. Okay. Now, third precaution is, benzene diazonium chloride is unstable in nature. So it decomposes with explosion when dried. It explode when dried. So solution should be, it means that compound should be in a solution, or that can be used in solution as such. Okay. it is always used in solution. It cannot be dried. As soon as it is formed, it is used in the solution itself. It cannot be dried or cannot be isolated. Okay, done. So these are the three precautions. First precaution is diazonium reaction can be carried out in ice cold solution, because at higher temperature it will react with water to form phenol. Second precaution is HCl should be in excess, because if HCl is not in excess, then what happened? It can form azodine immediately. Okay, it can combine with aniline, rest of the aniline, to form azodine. And third is, if it is dried, because it is highly unstable, so when it is dry, it can explode. Okay, therefore it is always used in solution as such. Okay, so these are the precautions. Now next is properties of diazonium salts. Now in properties, diazonium salt is, diazonium salt means it is ionic compound. Okay, so it is crystalline, it is colorless crystalline solid. Okay, but if it is exposed to air, it can become colored. Okay, but otherwise it is colorless crystalline solid because it is ionic. Okay, so being ionic in nature, it is soluble in water. Because it is ionic, so it is soluble in water, except benzene diazonium fluoride. Okay, only this one, it is insoluble in water because it is quite stable. Okay, it cannot break actually, right? And then next property we have done, okay, most of the salt decompose and even explode when dried. It should not be dry. Okay, it explode when dried. Okay, so it should not be dried up. Okay, now it is ionic, so its aqueous solution is good conductor of electricity. Okay, then other property, say diazonium salt of aromatic amines. It is comparatively stable from 273 to 278 Kelvin. Okay, but same salt of the aliphatic amines is highly unstable. Why it is stable? Because it is stabilized due to resonance, like this. See, it is stable due to resonance. Okay, I think this resonance part you know because you are in class 12th. So CN bond acquired double bond character due to resonance. But in case of aliphatic amine, there is no such thing. There is no resonance at all. Okay, that's why diazonium salt of aliphatic amine is highly unstable, or rather do not exist. Done. So these are the properties. Yes, not yes, you can say the dispersion of positive, but there is a double bond character actually. Okay, Now, chemical properties. Yes, diazonium salt, if it react with water, it become unstable. That will discuss in chemical properties. So let us discuss its chemical properties. So in chemical properties, there are two types of chemical properties. First is substitution reactions, or we can say replacement reactions. Okay. And second part is coupling reactions. Okay. So first of all, let us discuss these substitution reactions, in which what happened. वेरी गुड साहिल, फिनोल बनेगा, बिल्कुल सही बोला. ओके, इन दिस रिएक्शन व्हाट हैपन, डाइजो ग्रुप that is replaced by any monovalent group and nitrogen gas is evolved. Okay, so let us discuss the reactions. So I will write all the reactions in one go. See, aniline give diazonium salt. Okay, on diazotization we get aniline, this benzene diazonium chloride. Now this benzene diazonium chloride, if react with cuprous chloride, then we get chlorobenzene. If it react with cuprous bromide, we get bromobenzene. Okay, and these reactions are known as, okay, what are the name of these reactions? These are called Sandmeyer reaction. If there is a little modification, that we use copper powder in HCl or copper powder in HBr, again we get chlorobenzene and bromobenzene. Okay, so this is called, yes, what is the name of this reaction? Getterman reaction. Very good, beta. Now, with iodine, in this case we just treat it with, or we can warm it with potassium iodide, so we get iodobenzene, right? Now next is to form fluorobenzene. First of all, we treat it with hydrofluoroboric acid. Okay, so this gives this product. Okay, that is benzene diazonium tetrafluoroborate. Benzene diazonium tetrafluoroborate. Okay, which on heating gives rise to fluorobenzene. Yes, along with these we get nitrogen gas. Okay, here again we get nitrogen gas and BF3. Okay, and this reaction is called Ball-Schiemann reaction. In NCERT this name is not mentioned, but it is known as Ball-Schiemann reaction. Okay, now same, this tetrafluoroborate, if it is treated with rather than heating, it is treated with sodium nitrite in the presence of copper. We add sodium nitrite and copper powder in and heated, then we get nitrobenzene. okay, along with same products N2 and sodium tetrafluoroborate. Okay, so Sandman reaction, Getterman reaction, Ball-Schiemann reaction. Now, if the same diazonium salt is treated with CuCN, just like Sandman reactions, or with KCN in the presence of copper, then we get cyanobenzene along with CuCl and N2. Okay, here again Cu, this cyanobenzene along with KCl and N2. But yet cyanobenzene formed is highly reactive and it can be converted into benzylamine on reduction or benzoic acid on oxidation. See, this is cyanobenzene. It is also called benzene carbonitrile. So on hydrolysis, we get benzoic acid. Okay, and with on reduction, like with C2H5 in sodium, that is called Mendius reaction. Okay, so we get benzylamine. Benzylamine. Okay. Very good, Sahil. Great effort. Okay. So these are the reaction with CuCN and KCN. And then next is when benzene react with water. If we have aqueous solution of benzene diazonium chloride and it is warm, when we warm it with water, then what happened? Simply the precaution one, okay, we heat it or we warm it, means temperature is above 278 Kelvin. So benzene diazonium chloride is immediately converted into phenol. Okay, done. Now benzene diazonium chloride very good, Sahil. Now benzene diazonium chloride, if it is treated with benzene, okay, let us write it like this. This is benzene diazonium chloride. Now it is treated with benzene, okay, in the presence of sodium hydroxide. Okay, means we have alkaline medium. So then we get biphenyl as the product. We can call it as diphenyl or biphenyl along with N2, NaCl and H2. We call it as diphenyl or biphenyl. Okay. Yes. Next is simple reduction of diazonium salt. So reduction of diazonium salt that can be done with hypophosphorus acid or ethanol. Okay. So reduction, or we can say conversion of benzene diazonium chloride into benzene. So in this reaction, what we do, see, this is the diazonium salt. We treat it with hypophosphorus acid in the presence of cuprous ion, which is acting as a catalyst. So we get benzene along with phosphorus acid, HCl and N2. Very good. This is called phosphorus acid or phosphinic acid. Good. Or we can treat benzene diazonium chloride with ethanol. So it reduces the diazonium salt into benzene and itself gets oxidized, ethanol, to give acetaldehyde. Right? So these are the products formed. This is the first type of products. Okay. Now in second type, there is coupling reactions. Coupling reaction. So diazonium salts react with any reactive compound like phenol, naphthols, aromatic amines in again ice cold solutions, okay, to form dyes, and those dyes are called azo dyes, and reaction is called coupling reaction, and this reaction is carried out in a pH controlled medium. I tell you which medium is required. Like, see, if we have diazonium salt, now diazonium salt react with phenol. Okay, so you know phenol is an acid, so we use weakly alkaline medium. We use weakly alkaline medium, that is pH is 9 to 10. And if we have diazonium salt and it is treated with aniline, then if it is treated with aniline, okay, then you know aniline is a base, weak base, so we need weakly acidic medium. Why we need such mediums? I let you know. 4 to 5. pH is 4 to 5. So first of all, see this diazonium salt. See, this is the diazonium salt. So if lone pair, this pi bond moves towards positively charged nitrogen, so this is the electrophile. And you know OH is activating and orthopara directing, and this electrophile is bulkier, so obviously it attack at para position. So we get, this is called azo, N double bond N is called azo group. Okay, so with respect to OH at para position, this whole group is attached, so that is called para hydroxy azobenzene. Okay, and this O, so it is orange dye. Just to remember, okay, it doesn't mean that O means orange dye, but I have remembered it like this. If it is O, then it is orange dye, otherwise yellow dye. Okay, okay, with aniline now. With aniline, first of all, this whole thing, N double bond N gets attached like this. Okay, and then there is a rearrangement in acidic medium. So we get para-amino azobenzene. First one is para-hydroxy azobenzene. This is para-amino azobenzene, and it is, I think, yellow dye. Am I right? Oh, thank you, Harsh. Okay, so why we need these acidic or basic mediums? So I let you know. See, we have this electrophile. If medium is strongly acidic, sorry, strongly basic, okay, then what happened? Strongly basic medium, okay, so it becomes like this, means it is no more electrophilic. Okay, it is no more electrophilic, keep in mind. So we have to neutralize base. Okay, strongly basic medium makes it no more electrophilic. Second thing, like if we have aniline and medium is strongly acidic, then what happened? It gives rise to anilinium ion, which is highly deactivating group, so further reaction cannot take place. So that's why strongly acidic and strongly basic mediums are avoided. Okay, and to get rid of these things, what we do, we try to keep the pH, in case of phenol weakly acidic, sorry, in case of phenol weakly basic, and in case of aniline weakly acidic. Okay, got it? And you know why we need, if OH negative ions are dangerous, so why we use weakly basic medium in case of phenol? So you know, because phenol, if medium is weakly basic, then what happened? Phenol is converted into phenoxide ion, and you know phenoxide ion is more activating influence than that of phenol itself. Done? That's why it takes place. Okay, so phenoxide ion is more activating group. Okay, so pH जो है, that is allowed to increase beyond 10. Then what happened? If it is weakly basic, then phenoxide is formed, which can couples readily. But if pH is beyond 10, means highly basic medium, then we have written just now. Okay, yes, wait. In case of weakly or strongly basic medium, we get this product. Okay, which on further this one is formed, diazotate ion. Okay, and it does not couple. Okay, It does not couple. So beta, this is all about amines. Okay, whole chapter is completed. Okay, I will definitely cover this exercise, make a recorded videos, so that we will start another chapter, new chapter. Okay, and try to solve at your end the exercise part. So that's all for the day. Any doubt, please do ask. Yes beta, any doubt? Do you have any doubt? Any doubt? Beta, we are doing that part only. Okay, so next time we will start exercise of this chapter. Okay, and we will cover on the same tomorrow only. Okay, so it may